So let's now discuss about the effect of resistance of temperature to your resistance. So since you're talking about conductors, bear in your mind that a good conductor of electricity is also a good conductor of heat. Therefore, this formula will relate your resistance with temperature. Okay, so take note that in this formula you will notice that we have four parameters: your R1, R2, TO, T1, and your T2. Five parameters in total. So you have your T1 and R1. Your R1 and T1 indicates your initial resistance. This is the resistance wherein your problem, this is where your initial resistance will be the first given into your problem. So whatever the problem will state. Your R2 will be your unknown resistance, or T2 might be your unknown temperature. So take note that R1 varies with temperature, and your R2 also varies with temperature with respect to its T2. Your TO means that it is your absolute inferred temperature. So bakit nga ba meron tayong absolute inferred temperature? Basically, your temperature has a profound effect on the resistance, and hence, it is important that we can determine a method to find the resistance at any temperature within the limit of operation. So, although the temperature resistance curve is not a straight line, we draw a best fit straight line to find the resistance at a normal operating temperature range. So, our TO is the absolute inferred temperature of the material. Take note that it must be lower than your absolute zero temperature. Pag sinabi kasi nating absolute zero temperature is that it is a temperature wherein all conductors lose all of their electrical resistance when cooled to a super low temperature, so near about negative 273 degrees. So as you can see, in our figure 1, yung temperature natin or yung graph natin is not a straight line, but in order to connect it mathematically, we assume a straight line. Okay? Ito. We assume that it is behaving into a straight line or into a linear form. Alright? Yan. But since you have R1 and R2, so therefore, ang gagawin natin is that kukunin natin yung similar triangle natin. Okay? So, if you are talking about a similar triangle is that we will assume this point. Then yung point wherein we assume na yung straight line natin or our linear will be equal to 0. I-assume natin yan na maging triangle siya. You have our ito, yung top natin, let's say A, or your X 0, or your T of 0, X of 0, and then let this be your base or your height. Height 1, base 1. Height 2 at your R2, and this will be your base 2. Okay. So take note that the figure 1, we are showing that we are relating your temperature with resistance, assuming that we are getting or solving at inferred absolute zero temperature. Normally, your negative 234.5 is the inferred absolute temperature of a copper. Okay? So, why do we need to memorize this inferred absolute zero temperature? So, because there are probably that there is already a given material, and then hindi pa given yung AO niya, merong giving A1, A2, A3. Pag hindi mo kasi memorize yung ito, itong inferred absolute temperature ng isang material. Therefore, kailangan mo munang gawing A0 lahat ng A1, A2, A3 mo bago makuha yung sagot. Okay? Pero, pag memorize mo to, you can directly plug it into the formula even without relating your givens. Okay? So, this is your negative 234.5. Let's say this will be your TO. From 0 to TO. That is your X distance 1. X distance 1. Okay? From 0 to TO. Okay? Yan. Dito siya XD1. And then, from 0 to D1, 0 to T1, let's say that this will be your XD1, XD2. Okay? XD2. And then, let's relate that since this is your XD2, let's say that the whole distance of this triangle or your triangle 1 is this. Ano nga ba yung magiging length mo? Di ba? So, this is the graph of the green shaded triangle, which is your smaller triangle. Okay? Ito yung makikita nyo, di ba? So, this is your absolute or inferred IAT. So, gagawin ko na lang siya IAT. Stands for inferred absolute temperature. Papunta siya sa T1 mo. Okay? So, therefore, I may say that at my T1 or at my R1, so therefore, my length, ito, yung length na to, is that it has a length equal to this one. Your base 1 plus XD2. Okay? So, we have our 0 to 0, 0 to 20, T0, which is equal to XD1, and our 0 to T1, which is equal to your XD2. Therefore, this is equal to distance, or let's say this will be your X total 1, is equal to your 0 from 0 to 20 at the negative side, plus 0 to T1 at the positive side, right? Which is equal to, let's say that our XD1 will be this. Which is equal to our XD1 plus our XD2. But what is our XD1? Take note that our XD1, we have assumed that it is your 0 to T0 or simply your T sub 0. Ito di ba? T sub 0. Ito yung value mo from 0 to 2, 3, 4. Plus the value of your XD2 or from 0 to T1 plus T1. Okay? That is our distance 1, XT1, which is equal to TO plus T1. Take note that when you are talking about your triangle, we are dealing with what you call similar triangle. So, let's say that this is your theta. Your opposite side is H1. Opposite of your theta is H1. Let's say H1, I will relate this as your H1 over tan theta, opposite tan theta 1 is equal to opposite h1 all over opposite of xt1 or your adjacent xt1. Take note that tan theta is equal to opposite over adjacent, right? So our adjacent is your xt1. But what is your second equation? And then i-relate natin siya. Take note that your theta is also equal to tan theta is also equal to our h2 divided by our xt2. Right? So therefore I may say that since your tan theta, your theta 1 is equal to theta 2, therefore my tan theta 1 is equal to my tan theta 2. But what is my tan theta 1? It is equal to h1 all over xt1, which is also equal to your h2 divided by xt2. Okay? So kaya kinukuha natin siya. Since meron tayong xt1, so means meron tayong xt1, and also kunin natin yung h1. Okay? Take note that your h1 is equal to the value of this resistance 1. Alright? And then your h2 is the value of your resistance 2. Tama ba ito? Right? That is your R2 is equal to your H2. But what is our XT2? Just like what you have done in our XT1, madali lang yan, tama? So we have our XT2, which is equal to the distance of your T0 to 0, which is equal to your inferred absolute temperature. Okay? We have T0 plus our temperature at 2. Okay? Ito, 2. Para makuha natin yung buong area mo. Ito yung consider natin triangle. The orange triangle. If you are considering the orange triangle, you are considering the whole triangle from your inferred absolute temperature to your temperature at R2. Alright? So, this will be our inferred absolute triangle. So, i-extend ko to. Okay? This will be at R2 and T2. Okay? So, therefore, I may say that since may T0 ka dito at nandito yung reference natin at 0, so, therefore, my XT2 is just equal to from TO to T2. So, XTO plus T2. Okay? So, therefore, using this formula, meron na tayong mga givens, we may relate each other. Okay? So, relate natin siya using this formula. Alright? So, we have our H1 over XT1, which is equal to H2 all over XT2. But what is our H1? Our H1 is simply equal to R1, and our R2 is simply equal to H2 is equal to R2. And our XT1 is simply equal to TO plus T1. TO plus T1. And our XT2 is just equal to TO plus T2. Okay? So, by simple manipulation of formula, we can get the equation 3. Okay? So, you may say that is equal to R1 over R2 is equal to my, so R1 over R2 is equal to my TO plus T1 all over TO plus T2. Okay? So, ganoon lang siya, guys. Yan. So, there is already an explanation at the second page of this module, but probably this would help, as I have said, that it is just simple mathematics in relating our daily life. So, relate natin yung pagbabago ng temperature ng conductor using our graphs, which is, naglagay tayo ng inferred absolute temperature wherein it would cross more lesser than your absolute zero temperature. Okay? So, if you have noticed, we have negative values of this inferred absolute temperature. It is because your inferred absolute temperature is found at the negative portion of our Cartesian plane. Pero, kumbaga, mas mababa pa rin yung tinatawag nating absolute zero temperature, which is your negative 273 degrees Celsius. Okay? So, pera nga lang sa tinatawag nating nichrome. Okay? Kasi may tinatawag nating superconductivity. Pag more than negative 273 degrees Celsius ang isang conductor, nagiging superconductive siya. So, these are ito yung mga kadalasang ginagamit natin sa electrical engineering, yung silver, copper, aluminum. Okay, and also your tungsten para sa mga bulbs. So, you should know or memorize those temperature, inferred absolute temperature. Okay? Sir, pag plinag-in po ba namin sa formula, mag-negative pa rin yung gagamitin namin? No. You should always use the absolute value of this one. Unless, iba yung pinang-derive mo. But if you would use my derivation, that TO plus T2, I considered it as a distance of a base of a triangle. So, therefore, gagawin mo siyang absolute value. Dapat yung isa-substitute po sa formula is in positive form. Okay? Any question, guys? So wala, no? Kasi online naman. Oh, derivation yan. So, next is our, what you call, the temperature coefficient. So, your temperature coefficient is what you call your AX. Your AX may be A1, A2, and A3 depending on what temperature it is in. So, ang gagawin mo lang para makuha mo yung tinatawag nating temperature coefficient is that, ito, solve for or use the formula. Formula based, okay? Very easy. No need of analysis. Just use the formula correctly. Yan, di ba? Kahit alam mo yung formula, pag mali yung analysis mo, syempre, mali pa rin. Okay? So, this will be our, what you call the temperature coefficient. So guys, kung nagtataka kayo, bakit kailangan pa natin ng temperature coefficient? Eh, meron na tayong formula wherein relate natin yung resistance at temperature. Actually, yung temperature coefficient of resistance nyo is also the measure of the change in electrical resistance of any substance per degree of temperature change. Okay? So, this means that it is equal to anong unit ng temperature resistance nyo? It is equal to per degrees Celsius. Okay? Dapat naka per degrees Celsius yan. Kasi later on, we will use the formula of this one. Yung like resistance natin, Rf is equal to R1 times 1 plus alpha 1 delta T. Since delta T to, understood, no, kailangan makancel ito, di ba? So therefore, I may say that my temperature coefficient has a has a unit of per degrees over degrees Celsius. Okay? So, may derivation actually ito, pero hindi ko na i-derive. Okay? Kasi naghahabol na tayo. So, these are, in our table 2, you can see that we may have the coefficient of resistance or resistivity of some metals, temperature coefficients. So, 3.8 times 10 raised to negative 3 degrees Celsius, 3.4 times 10 raised to negative 3 degrees Celsius, 5.0 5.0 times 10 raised to negative 3 degrees Celsius. 0.4 times 10 raised to negative 3 degrees Celsius. So 3.9 times 10 raised to negative 3 degrees Celsius. Halos parehas sila ng aluminum. And then yung tungsten natin and your platinum. Okay. So paano nga ba nakuha to? Actually, so sabi yun dito, the table 2 shows the temperature coefficient of each material, but take note that these temperature coefficients are applicable at room temperature equal to 20 degrees Celsius. So 20 degrees Celsius. So take note that our A at 20 is equal to 1 divided by TO plus 20 degrees. So example is our copper. So our copper has equal to TO at copper is equal to 234.5 degrees Celsius. Alright? So if we have 1 divided by our TO, which is equal to 234.5 degrees Celsius plus 20 degrees, what will you solve? You have a value equal to your alpha 20 of copper. 1 divided by 234.5 plus 20. You have a value equal to 3.92927 times 10 raised to negative 3. So which is approximately equal to your value of your temperature coefficient of your copper. Okay? So pag hindi kayo convinced sa mga value nito, ang gagawin nyo lang is that i-add nyo lang yung 20 degrees Celsius sa baba kasi nga nasa TO tayo at T1 natin at 20 degrees Celsius. Okay? 3.92927 times 10 raised to negative 3. Sir, ba't nasa 20 degrees Celsius yan? Nasa table yan. Ba't hindi 0? So, kung gusto nyo kunin yung 0, edi let T1 be equal to 0. So, therefore, my alpha 0 is equal to 1 divided by my TO. But what is my TO? At copper, your TO at copper is equal to 234.5. Okay? 200, wala nang igaganda. Ang pangit ng sulat ko, guys. Pasensya na. So, 1 divided by 234.5. Okay? Which is equal to 1 divided by 234.5 is equal to 4.26 times 10 raised to negative 3. This is your alpha 0 of copper. Okay, take note. In order to check this one, ang gagawin lang natin is lahat yan. So, para mag-convince kayo, so alpha at 20 degrees is equal to 1 divided by TO of the material plus 20. Yan. Yan yung sagot natin na formula. So, per degree Celsius yan. Per degree Celsius din to. Okay? May mga tanong, guys? Pag may tanong, just comment down below. Okay. We may also relate our temperature with the variations of your resistivity. So, pag nagbabago yung resistivity mo, ibig sabihin, nagbabari din yung resistivity mo, resistivity ng material mo with respect to temperature. So, which is given by this formula. Rho F is equal to rho 1 multiplied by 1 plus alpha 1 multiplied by Tf minus T1. Actually, Tf minus T1 can be relatable into T2 minus T1. Okay? So, this is our example for our lesson number 2 in our module 2. Okay? So, we have, if the resistance of a copper wire is 50 ohms at 20 degrees Celsius, what is the resistance at 100 degrees Celsius? So, take note that we have a copper wire. Right? So, therefore, we will build, that is, illustrate this into the graph. Okay? So, let's say this is your copper wire R. R2 and your R1. Okay, so this is your inferred absolute temperature. Take note that we have our absolute temperature, okay, which is equal to negative 270 degrees Celsius. So based on the table, so browse your module in the table, we have an inferred absolute temperature for copper, which is equal to 234.5 degrees Celsius. Okay, so we have our 0 degrees Celsius, and we have 20 degrees Celsius and 100 degrees Celsius. Also, we have your R1, which is equal to 50 ohms, and your R2, which is equal to unknown. Okay, so therefore we may solve. Okay, let's shade it. So this will be our first triangle. So as I have constructed the formula, so this will be our first triangle, wherein our x, or your T, which is equal to your temperature, and this is your resistance. Your x, which is equal to your temperature total, is equal to TO plus 20. This will be your x1. Okay, so take note that use the absolute value of your TO kasi ginawa natin siya outside of a triangle, right? So therefore, we have a value equal to TO plus 20 degrees Celsius. That is our x1. What is our x2 then? So our x2 is probably this length. Okay, we have x2, which is equal to your total, which is equal to TO plus 100 degrees Celsius. Okay, but what is your x2? Your x2 therefore is equal to this figure. Okay, we have a value equal to TO plus 100 degrees Celsius. Wherein, take note that our TO is equal to the absolute value of 234.5 degrees Celsius. Alright, so therefore it is equal to 234.5 plus 20 degrees Celsius is equal to, okay, 264.5 degrees Celsius, or 254.5 degrees Celsius. That is our x1, and our x2 is probably equal to 234.5 degrees Celsius, so absolute value, plus 100 degrees Celsius, it is equal to 334.5 degrees Celsius. Okay, so using our similar triangle, so this will be our theta. So therefore we have tan theta 1 is equal to opposite, which is equal to opposite over your adjacent. Our opposite is equal to our resistance 1, which is equal to R1, all over our adjacent is our x1, which is therefore equal to 50 ohms divided by our x1, which is equal to 254.5 degrees Celsius. What is our tan theta 1? Tan theta 2. So take note that your tan theta 1 is equal to your tan theta 2, which is also equal to R2 over x2. Take note that our R2 is unknown. So let's say this will be your R2 divided by X2, which is equal to 334.3 degrees Celsius. 334.5 degrees Celsius. Okay. So tan theta 1 is equal to tan theta 2. Therefore, I may say that it is equal to R1 over my X1 is equal to my R2 all over my X2. Right? Our R1 is equal to 50 over 254.5 degrees Celsius, which is equal to our R2 divided by 334.5 degrees Celsius. Okay, solving for R2, we have R2 is equal to, so cross multiply, yan, we have our R2 which is equal to 50 multiplied by 334.5 degrees Celsius divided by our 254.5 degrees Celsius, which is equal to 65.71 ohm or 65.717 ohm. Okay. This is our example 1. Proceed to example number 2. So a coil has a resistance of 18 ohms when its temperature is 20 degrees Celsius and 20 ohms when its mean temperature is 50 degrees Celsius. So find its mean temperature rise when its resistance is 21 ohms and the surrounding temperature is 15 degrees Celsius. So ibig sabihin is that nag-increase yung temperature mo. And then, at a time, when meron siyang 15 degrees Celsius sa surrounding temperature, so that what would be the mean temperature? Okay. So first, let us solve for our mean temperature. Mean temperature rise. Okay. So when you are talking about mean temperature rise, is that you are comparing the temperature minus your surrounding. Okay. So we have, how will we solve this? So first, since mahirap siyang isipin muna, so i-tabulate natin yung given. We have your R1 which is equal to your 18 ohms, sabi niya, at 20 degrees Celsius. And then, we have our R2, which is equal to 20 ohms, when its temperature is 50 degrees Celsius. And then, we have your R3, which is equal to 21 ohms, at unknown temperature, minus 15 degrees Celsius. TF. Okay. So, since there are 3 resistances involved, now let's make a graph in order to represent each of them. So we have R1, which is equal to 18 ohms. We have our R2, which is equal to 20 ohms. And our R3, which is equal to 21 ohms. And then we have T1, which is equal to 20 degrees Celsius. T2, which is equal to 50 degrees Celsius. And our T3, or your TF. Okay. So since you have already this concept, so let's do the graph. So our graph will be like this, right? Straight line niya. So sabi mo na lang, nandito yung TO mo. Okay. Should be straight yan. So this will be your TO. This will be your T2. T2. And then your R3. Ito. Yan. So, we have 3 triangles to compare. Okay? But, we have our TO. So, take note, wala siyang sinabing klase ng material. Since wala siyang sinabing material, so therefore, we may not assume it is copper. Huwag kayong magka-assume pag hindi sinabi, di ba? Masasaktan lang kayo pag mali. Okay? So, we have our TO is equal to unknown. Okay? So, therefore, what would be our next strategy or next step? So, gaya lang din ng dati, kukunin natin yung triangle mo. So, let's say this will be your triangle 1. Okay? Wherein our triangle 1 will be equal to your x1, y1. Alright? So, what is our y1? Take note that our y1 is just equal to your r1, which is equal to 18 ohms. Alright, 18 ohms. Hindi siya maintindihan niya. Pag hindi nyo maintindihan, huwag nyo agad bitawan. Di ba? Hanapin nyo muna ulit yung given. Okay? Since intindihan na natin, tuloy natin. Okay? We have R1 is equal to 80. And then yung T1 natin, or your X1, is equal to your TO plus T1. TO plus T1, di ba? TO plus T1. Alright. We have our TO, which is equal to unknown, plus our T1, which is equal to 20 degrees Celsius. Alright. And then, kukunin natin yung x2 natin. So, we have our x2. So, we have this triangle. So, our x2 is equal to TO plus T2. Wherein our TO is unknown, plus our T2 is equal to 50 degrees Celsius. That is our T2. And Y. And then our Y2 is equal to your R2, which is equal to 20 ohms. Okay. Next is our Y3 and your R3. Your R3 is equal to your Y3, which is equal to our 21 ohms. And our T3 is unknown. But we all know that our X3 is equal to TO plus T3. So, dalawang unknown dito sa X3. So, take note that if there are two equations to unknown, there should be two equations that would denote the equation of the other. That would describe the other function with respect to the other function. Okay? Since your X3 needs a description on its T3, which is equal to unknown, so first, let's solve for TO, wherein your TO will give you an exact answer for your X3. Okay? So, let's solve for the problem. Okay. What are our exact equations to be used? So, sir, anong gagawin natin? So, we have denoted your XT, R1, and R2. Kasi nga, isa lang yung unknown natin, which is your TO, which is relating them to each other. Okay? So, therefore, I may say that my TO is equal to TO plus T1 minus 20 degrees Celsius. Okay? Which is equal to the function TO. Diba? Pwede mo siya substitute agad. Pero basically, ang gagawin natin is yung triangle natin. So, we have SOHCAHTOA. We have our opposite over adjacent. Our opposite at x1 is equal to y1 over opposite of and our adjacent is x1. Right? If you consider that this will be your theta. This will be your opposite. This will be your adjacent. Tama ba? Yun lang din sa triangle 2. We have our opposite which is equal to your y2 all over our adjacent which is equal to x2. Okay. What is our y1? Our y1 is equal to 18 over our x1 which is equal to TO plus 20, which is equal to our y2, which is equal to 20, all over our x2, which is equal to TO plus 50. Solving for the value of TO, so therefore we can say that TO is equal to, so 18 multiplied by TO plus 50, which is equal to 20 multiplied by TO plus 50, plus 20. Okay? Okay lang, di ba? Alright. Alright. We have our 18 TO plus 50 multiplied by 18, which is equal to our 20 TO plus 20 squared. 20 multiplied by 20. Alright? So we will now transpose your values in order to get a function or the value of your variable TO. We have 50 multiplied by 18 minus 20 squared is equal to 20 TO minus 18 TO. So we have 2 TO is equal to 50 multiplied by 18 minus 20 squared. So gusto ko sanang ipakita using my calculator pero baka matagal ulit. Okay? So we have 500. So what is our TO therefore? So we have our TO, which is equal to 2 TO, which is equal to 250 degrees Celsius. That is our TO. Okay, tama ba? Next, we have our T1. We will now solve for our T3. Okay? So, meron na tayong TO, which is equal to 250 degrees Celsius. So, therefore, we may say that our x3 is equal to 250 plus T3. Tama ba? So, since may 250 plus T3 tayo, we are now ready to solve for our T3. Solving for T3. Okay. Ano next na gagawin natin? I-relate na lang natin ulit siya. So, this is your T3. Okay, hindi siya makikita ito. This will be your T3. The whole triangle. So, what will we do is to go back to the basics. So, since you already know your y1, so kahit anong equation ang gagamitin natin dito sa dalawa. So, either y2, x2, or your y1 and x1. Okay? So, since you have already your 250 plus t3, we will now solve for your r3 all over x3, which is equal to your, let's say kahit r1 over x1 na lang. Okay? So, pwede lang ang x2 over, r2 over x2, guys. So, our r3 is equal to 21 ohms over x3, which is equal to 250 plus t3. And also our r1, which is equal to r1 is equal to our 18 ohms, right? 18 ohms all over 250 plus our T1, which is equal to 20 degrees Celsius plus 20. So, solving for 3T, we have, so, pag ganyan, pwede kayo mag-shift solve, okay? So, 250 plus 20 multiplied by 21, so, cross multiplication is equal to 18 multiplied by 250 plus T3. Okay, so we have 270 times 21, it is equal to 5670. 5670 plus anong unit, sir? Okay, yung unit niya is ohm multiplied by degree Celsius. Yan, diba? Is equal to 18 multiplied by, so 18 ohm multiplied by 250 degrees Celsius. Okay, plus our T3 plus 18 ohm multiplied by T3, right? So we have 5670 minus 5670 ohm degrees Celsius minus 18 ohm 250 degrees Celsius. So we have a value equal to our 18 ohm T3. Okay, so 5670 minus 18 times 250, we get a value equal to 1170 ohm degrees Celsius, which is equal to 18 ohm T3. Okay, solving for the value of T3, let us divide both sides by 18 ohm. So we have our T3 is equal to 1170 ohm degrees Celsius divided by 18 ohm. Okay, so therefore we may have a value equal to 1170 divided by 18 is equal to 65 degrees Celsius. This is your temperature at T3. Okay, but since there is a surrounding temperature of 15 degrees Celsius at this moment, so therefore let's get the temperature difference. So delta T is equal to T3 minus 15 degrees Celsius, which is equal to 65 minus 15 degrees Celsius, it is equal to 50 degrees Celsius. This is your T difference, T diff or T delta. Okay, yeah. Okay, yeah. So any question, guys? Napakadali, di ba? So try solving the other example. So this will serve as your practice problem. Okay, next example. This will be our last example for this topic. So if you have problems in solving the different examples, just ask, just feel free to ask, or just comment your suggestions below. So next is so that the resistance of a copper wire at 30 degrees Celsius is 50 ohms. If the temperature coefficient of copper at 0 degrees Celsius is 0.00427, what is the resistance at 100 degrees Celsius? So take note that we can solve your A0 in your A30 into different situation. So since we have our material which is copper, so we all know that the TO of your copper is equal to TO of copper is equal to 234.5. Okay, so using our temperature coefficient, we will solve for A30. You all know that it is equal to AO all over 1 plus AO multiplied by Tn. Okay, this is on your, this equation is on your module. And also similarly, your AO your A30 is equal to 1 all over 30 plus 234.5, or your 1 all over T plus your TO. Alright, so using our first equation, so our AO, which has, we have our AO which is equal to 0.00427 divided by 1 plus 0.00427 multiplied by Tn. Take note that your Tn is equal to 30 degrees Celsius, which means this is temperature at 30 degrees Celsius, which is equal to 30 degrees Celsius. Alright? So we have 0.00427 divided by 1 plus 0.00427 multiplied by our 30. Okay, we have a value equal to 0.00427 divided by 1 plus 0.00427 multiplied by 30. So use your calculator. We have a value equal to 3.785 times 10 raised to negative 3 degrees per degrees Celsius. So this is the important thing when you know about your TO. So let us use or compare the answer if we use this equation. We have 1 all over 1 T plus TO. 1 all over T N plus TO. Wherein our Tn is equal to 30 degrees Celsius plus our TO, which is equal to 234.5 degrees Celsius. So what is your answer? This is your A30. Alright? So what is your answer, guys? 1 all over 30 plus 234.5 over all over 30 plus 234.5. So we have a value equal to 3.78 times 10 raised to negative 3, which is primarily approximately equal to your 3.785 times 10 raised to negative 30. Okay? So 3.78 times 10 raised to negative 3. So pwede ko bang gamitin yan pag sakali? Okay lang. Pwede. As long as you would relate it to the problem. Okay? So what is the resistance at 100 degrees Celsius? Okay. So let us use your formula of your resistance with respect to your temperature. We have your RF is equal to R1 multiplied by 1 plus alpha delta T. Okay, this is another formula. Okay, so you have our RF is equal to your R1 is probably equal to, is the value of our R1, it is equal to 50 ohms. R1 is equal to 50 ohms and your T1 is equal to T1 is equal to 30 degrees Celsius. Right? So we will break down your equation. We have R1 multiplied by 1 plus our alpha. This must be at your 30 degrees because our R1 is at 30 degrees Celsius. Delta. Sir, ba't hindi ko pwedeng gamitin yung 0? So, alpha 0 is not equal to alpha 30. So, if you would use alpha 0 in this equation, perhaps you should use your R0. Okay? But, since we have given your R1, which is equal to 30 degrees Celsius, therefore, 50 ohms at 30 degrees Celsius, therefore, our alpha that would be used must be the same as the temperature coefficient. Kaya nga siya yung temperature coefficient because it varies with the temperature. Okay? So, we have our TF is equal to 100 degrees Celsius. Sir, bakit din hindi ko gamitin yung TF ko? So, take note that R1 or your subscript 1 or your initials are the quantities or characteristics wherein you will base your answer. So, mag-iiba siya. Dito siya galing, papunta siya sa R2. Okay? Kaya ang gagamitin mo is that your initials. Kung ano yung pinakaunang characteristics mo. Your initials R1 and your T1 with respect to your temperature coefficient. So, therefore, we must use our alpha 1 or your alpha at 30 degrees Celsius. Take note that your R at 30 degrees Celsius is equal to 50 ohms. And then our alpha at 30 degrees Celsius is equal to 3.785 times 10 raised to negative 3 from your calculator. Siyempre multiplied by your delta T. Take note that delta denotes a change wherein is equal to final minus your initial or simply your T2 minus T1. Okay? We have 50 multiplied by 1 plus 3.785 times 10 raised to negative 3 multiplied by our TF, which is equal to 100 degrees Celsius, minus our TI, which is equal to 30 degrees Celsius. So solving for the problem using your calculator, we have 50 times 1 plus 3.785 times 10 raised to negative 3 multiplied by 100 minus 30. So what is your answer? Guys? It is equal to Copy guys yan. Sabay na pindot ko. Okay? Wait lang Syntax error. So times 70. Yan. So we have a value equal to 63.2475 ohms. 63.2475 ohms. Okay, I suggest that you should recalculate the value. Alright? So, sir, applicable po ba yung first solutions natin? Yes, it is applicable because these two are correlated. Okay? So, this is our last example for this topic. Okay? So, review for a quiz or sit work next week or this week.